Okay, this is our project 2. In the last minute, we built this really awesome security alarm that's better than any security alarm that anyone else might have built in this class or not. So what we have right here is this little laser with its own breadboard, and just getting powered by 2 AA's, and it's being pointed at this Mindstorm's light sensor. And to basically feed that into LabVIEW, which here's our block diagram. And so what happens is, when this laser gets broken, it sends a signal through the lab jack to pulse this voltage, which in fact goes to this little LED in this little black sleeve, which is pressed against a photoresistor. And what that LED does is fluctuate the pitch of this signal generator we have, therefore putting out this really annoying signal. So basically it's like an alarm. So I'm going to turn it on right now, and when you turn it on, we just have this basic like background sound, which is a good like deterrent, you know, because the bad guy you'd hear that and you'd be annoyed. But then if he breaks the laser, he's like, oh, I'm screwed. So if we have this, all right. So if I go ahead and break the beam, the alarm goes off. And then if you see on the computer, there's a huge the security guard down the hallway. You know, you would see that something's going wrong. Yeah, it's pretty cool. And we have a LED right here that flashes for good measure. Flashes at the frequency of the sound. So one thing we learned, even though we didn't end up using them, we learned how to use the relays and how to use like pull-up resistors and transistors, because originally we wanted to switch our circuit on and off for our previous project 2, but we didn't end up using that. So even though we didn't use it, we still learned about the relays and transistors and the opti oscillators that we learned about in class. We learned how to actually use them, even though we didn't end up using them. And the project's not much different from project 1 on this breadboard, because it's just a signal generator, but basically we control the pitch with this little LED. You actually see, if you come in here, you can see the LED flashes in there. And so that changes the pitch. So just for good measure, we want to show Bensky that our project is LabVIEW driven with a computer input and output. So here we have our computer input, which is the NXT, and the output, which is the lab jack. We have beautiful breadboarding, very beautiful. We have our custom LabVIEW code that we made today, and we told you what we learned. And this video is clearly upbeat, watchable, and summarizes all the points below, so there's no reason we shouldn't get a 35 out of 35.